Welcome to Ask and Learn.
So our question is asking us about it's referencing to our group 1 and 2 columns or groups in the periodic table. So one thing that we can look at with our periodic table, we'll see that our groups 1A and 2A, they have a certain number of electrons each. So we know that in group 1, they have 1 electron in their valence shell, and in group 2A, they have 2 electrons in their valence shell. And remember that group 1 are called the alkali metals, and group 2, they're called alkaline metals. Both of these groups are very reactive. We know that these are metal groups, so each of these elements or atoms, elements of these two groups are very reactive because they are metals. We know that metals are good conductors of heat, of electricity, and therefore would most likely serve a very significant role in our electrolysis process that was mentioned in the problem. So when we say that they're good conductors of electricity or that they are good conductors of heat, what what is meant is that these electrons, these valence electrons, are easy to react with our nonmetals that are over here. So we have our noble gases on the very, very far right. We've got our halogens that are very reactive as well. And so these are our nonmetals. And whenever a nonmetal bonds with a metal, we have an ionic reaction or an ionic bond. And so that's what's happening here. So because these two columns, our alkali metals and alkaline metals in group 1 and 2, have only 1 or 2 electrons in their valence shell, they are again more reactive, and also what makes them more reactive is they easily give up their electrons because they want to be whole or complete like the noble gases. So what they do to try to satisfy this is they try to bond with other elements of the nonmetals. For instance, elements in the nonmetal or the halogen group. And so again, we form our ionic bonding. So when we look at this in an electrolysis reaction, we know that electrolysis is a process in which ionic substances are decomposed or broken down into a more simple form. And that's when an electric current is passed through them. And so what happens is we end up adding heat and breaking down a substance like the sodium chloride, and we end up forming these elements. So this is an example of electrophoresis. We have heated the sodium chloride solution, and now the electrons have been dispersed. And again, with ionic bonds, we know that we're going to have electrolytes, and they're going to break up, and our electrons will flow from our anode to our cathode, and therefore we have these elements form. So this is a halogen, chlorine, and then we have sodium form on the other side, on our cathode side. And we can see that just like we talked about, sodium is part of one of these two groups. If you look on your periodic table, you'll find sodium. It should be in the group 1, and so therefore it's very reactive as was mentioned earlier. And we have our chlorine or chloride that's on our nonmetal side in our halogens group. It's also very reactive, and there you have it.